Alrighty, let's see. What we want to do in this one is we want to now go the other direction. We want to start off with a growth factor, and we want to find the growth or decay rate. So what we're hoping to get, we want a percentage. That's what we're hoping to end with. And we're starting with the factor. And so as a reminder, the formula for growth and decay in exponentials looks like this. And in this scenario, we are starting with the entire factor, all of this, and we want to know what our growth rate or decay rate as a percentage is. So the process is very similar. We're just going the other direction. Rather than starting with R, we're going to start with the whole big picture. So first off, let's take a look at the first one. We know that this is going to be a growth because this is bigger than 1. So growth is the first thing we want to identify. If we're dealing with a growth, that means that our factor, our growth factor, is going to equal 1 plus our rate. So we know what our whole factor is, though. We know that it's equal to 1.345. And if that's equal to 1 plus our rate, then all we're doing is we're subtracting 1 from both sides of these equations to find out what our R is. It's just a simple algebra problem here. So our rate is going to end up being 0.345. Now that's a rate as a decimal. We need a percentage out of this. So the only thing we need to do now is move our decimal place over 2 places to the right, and our final rate as a percentage is going to be 34.5%. If you wanted to check, you can go the other direction. You can start with this as a rate and see what the growth factor would become, and you should get the same exact thing. If you don't, then you need to see what you did wrong there. For this last one here, we're going to start off with this looks like a decay factor of 0.88. Now, the reason I knew that so fast is because if I am less than 1, then I am going to be looking at a decay factor because it is my factor is less than 1, so this is a decay, not a growth. But the process stays the same. My factor is still going to be given by this equation, but now, rather than having my 1 plus my R be my growth factor, it's going to be actually 1 minus my R since I'm dealing with a decay rate. So my factor is 0.88, and that's going to equal 1 minus R. If I subtract 1 again from both sides of this equation, I'm coming out with a 0.12, or rather a negative 0.12 equals negative R. I can flip both signs by multiplying everything by a negative 1, and my rate, my decay rate, is going to end up being 0.12. If I slide that rate over, or rather that decimal place over 2 positions, my rate as a percentage is going to be 12%. And since this is decay, let's just note that, 12% decay. And there you go.